Hey guys, this is Tyler Christofoli from Spec, and today we're going to talk just a little bit about ABG interpretation. So we're doing a critical care transport, and we're trying to figure out how to make sense of their arterial blood gases values that we get. So what I like to do is, if I'm using a tough book or a piece of paper, I just like to draw a tic-tac-toe symbol on the paper, or the notes on the there's a little note tab on the bottom of the tough book. And over the left side, we're going to write A for acidity. In the middle, we'll do a N for neutral or normal. And on the far right, we'll do a B for base or alkalotic. And then over on the left side, our first bracket is going to be CO2. Our second one is going to be our bicarb, HCO3. And at the bottom, we'll do our pH. So before we get into this, we need to remember that CO2 is more of our respiratory value and bicarb is more of our metabolic value. So knowing these, it can help us better interpret our arterial blood gases. So I'm going to throw a couple values at us, and we're going to put them in as like we would play tic-tac-toe, put the X's where they belong. So we'll say we get a patient with a pH of 7.30. So we know this is more on the acidic side. So we're going to draw an X where the pH is, where it lines up with the acidic. So now we get let's say we get a CO2. All right, we'll work our way up. We'll say we have a bicarb, an HCO3 of, let's say our bicarb is 50. So we know a normal bicarb is around 22 to 28. So this is more on the alkalotic side. So we're going to put an X over here. It's more base. Now we'll say we have a CO2 of, let's say our CO2 is 54. Well, a normal CO2 reading is normally 35 to 45. So we can see this is more acidic. So we're going to draw an X by the CO2 on the acidic side. So now we can see that we have more X's on this side than we do over here. So we know we have something acidosis. Well, since we have CO2 up here, we have a respiratory acidosis. So now we have to figure out if it's compensating, and if it is compensating, what's compensating for it? So in this situation at 7.30, we know we're not fully compensated, we're partially compensated. Well, what makes us partially compensated? Well, if we look at our bicarb value was 54, which is more base. So we can see that our bicarb is increasing to try to neutralize the body's pH. So doing this simple tic-tac-toe method I like it a lot because it's a very visual aid to help you try to diagnose the patient's arterial blood gas, so we can better prepare our vent settings and get a good idea of how the patient's body is compensating for any acidosis or alkalosis that it comes across. So I hope you guys found this useful. If you guys have any questions or comments, leave them in the box below. Thank you very much for supporting Spec.
Made with Doodlecast Pro.